What is sim-to-real transfer in robotics? Imagine training a robot in a virtual world where it can try out different actions without any risk or cost. Now, picture that robot taking what it learned and doing it in the real world. That's what sim-to-real transfer is all about. In robotics, sim-to-real transfer means teaching robots in computer simulations and then applying those lessons to real machines. Instead of practicing on actual robots all the time, which can be slow and expensive, developers use virtual environments to speed things up. Robots can learn to pick up objects, navigate spaces, or assemble parts in the simulation first. Once they get good there, the skills are transferred to real robots. The main reason for this approach is to bridge the gap between virtual and real worlds. Simulations are easier to control and safer for testing new ideas. They also save money because you don't need to build or risk damaging physical robots early on. But there are challenges. The real world is messier than simulations. Cameras might see differently, surfaces may have more friction, and lighting or temperature can change unexpectedly. To fix these issues, researchers use techniques like domain randomization. This means changing simulation settings randomly during training, such as textures or lighting, so robots learn to handle many different situations. They also use domain adaptation, which adjusts simulated images to look more like real ones using machine learning models. Transfer learning helps by taking skills learned in simulation and fine-tuning them with a little real-world data. System identification involves making the simulation match the real robot's behavior more closely by calibrating sensors and physics models. Deep learning plays a big role here. Robots are often trained with deep reinforcement learning, where they learn by trial and error in the virtual world. Once trained, these policies are moved to real robots. Sometimes, additional adjustments are needed to handle real-world noise and unpredictability. This process is used in many practical ways. For example, robots learn to assemble tiny electronic parts with high precision. They also learn to grasp objects of different shapes and sizes, even in cluttered environments. Autonomous vehicles use sim-to-real transfer to navigate safely in complex settings. Recently, some robots can go straight from simulation to real-world tasks without extra tuning. This is called zero-shot transfer and is especially useful in manufacturing and service robots, where quick adaptation is key. In essence, sim-to-real transfer speeds up robot development by letting machines learn in safe, virtual spaces and then perform well in the real world. It combines simulation, machine learning, and careful calibration to make robots smarter and more adaptable. This method is shaping the future of robotics and artificial intelligence by making robots more capable and ready for real-life challenges.